Alright, there we go. Hey everyone, welcome back. And today we'll be beginning with a new series. I guess I can call it series now. Um, yeah. So today we'll be doing some or practicing some Codewars. I think this is gonna be my first session that I have ever done like through streaming on Codewars. So yeah, here we go. We'll be practicing some Node.js questions today. So let's get started. So, to those who are not familiar with Codewars, I like to think of Codewars as lead code, but it's sort of gamified, for lack of a better word. Um, yeah, it it basically you have to solve a couple of problems, or you have to solve coding related problems that they post on the site, and yeah, that's it really. I personally use Code Wars to just you know get better at, like, whenever I learn a language, right, I use Code Wars to practice the language. Yeah, solve some common problems by using the language. So as I say, it's all about practice. Yeah, I just created this brand new account, and I'll be solving questions on this. I'll I'm also sort of planning to push my solutions onto GitHub. I've created a repository. Link is down. You just scroll down on Twitch and you'll find my GitHub and you can access it. But yeah. So yeah, let's get started. We'll begin with some Node.js questions. So, or Node.js problems rather. It feels weird calling them questions. But yeah. So, so on Codewars, they classified problems into certain levels, and it's the lower the number is, the harder the problem is. I found it quite strange when I began, but yeah. So basically, there are eight such. How do you pronounce this? Q levels, I guess. And it gets harder as you go from 8 to 1, 8 being the easiest and 1 being the hardest. um yeah, I think that should be a brief summary on what Codewars is. And what I've set out for myself is that I'll be trying to keep my Codewars, at least for this stream, between 8, 7, maybe 6. We have to see. And another rule will be there that, like, I'll try a problem, right? And if I can't make any progress in it for, let's say, I'm stuck on it for like 10 minutes, maybe we'll increase it. But if I'm stuck on it for 10 or like 15 minutes or something, I'll just move on. I'll just look at the solution and just move on. So, yeah. With that being said, let's begin. So, which problem should we take as our first challenge? So let's see. This reminds me of the get batches. I think that's what the problem is, though. Problem is to, like, given a larger array, just make batches out of it. Stack. What's this? Let's check this out. Let's read this. Okay, this feels okay. I guess we can make this our first problem. So let's just read the description here. Life isn't always easy as a small world amongst big words. Only they had a okay. The task is to make all three words which are three characters or less into capitals. Oh, I see. So the will become the with all letters uppercase. Okay, there's another condition. Let's check. You should also remove any vowels from long four characters or more words. I see. So A E I O U is Y also cons. No, I'm not sure, but Y is Y vowel. Yeah, there's something crazy with that. Generally, it's A E I O U. So and that's what they've considered here too. So let's go with that. So O is removed here. This is a three-letter word, so it gets converted into uppercase. U is removed. I think I have understood what the problem is. So let's start coding. Oh wait, what's this? For the purpose of mid-word punctuation counts towards. Okay, so I see. Like not only letters but punctuation is also considered, or this type of punctuation is also considered as a character for the purpose of this problem. I should use the word kata, I guess. Oh, I'll just take the problem. Okay, it should become okay. I is removed. This is considered to have three characters in it, and hence it's turned into uppercase. Wait, why isn't I removed? Shouldn't I be removed from there? Maybe it doesn't apply to capital. Oh, wait a second. Oh, never mind. Like if the first condition is met that it is a three-letter word, then we don't remove any vowels or anything. We just convert it into uppercase. We only remove vowels if it's greater than or four characters or more. So yeah, let's start with let me just okay, I guess what I'll do is I'll copy this link here and we'll just name the files as 1.js, 2.js and so on. Let's add the problem link at the beginning as a comment and let's start. So so let's see how we can do this. Okay, we can first of all get all the words, right, that are within the sentence, iterate through the words and then apply the logic. Yeah, I think we can do that. So, let's get the words. So we use the, I believe it's a split method. And then rather than using a for loop, how about we use a map, right? And I believe a map um, returns a list, right? A new list. So let new words equal words dot map. So we take the word, and this is what we are gonna do. So if word dot can we no I think that's wrong. Um, let's see. ABC. Is this how we? Yeah, that is how we get the length. So no, never mind. That's correct. So if word dot length, oh, it needs to be wrapped around within the bracket. If that's equal to 3, then we return word dot to uppercase. Else if word dot length is greater than or equal to 4, we can strip them of vowels, right? Yeah, and punctuation is also considered, so we should be good there. So what would be the easiest way to check if a vowel is within the word? Yeah, let's define vowel or the vowels as A, E, I, O, U. And let's also does the case, so I'm trying to check if the casing matters for the word. All these sentences are lowercase. Okay, just to be sure, we'll convert the word to a lowercase and then we'll remove the vowel if it even contains the vowel. So how do we do this? We can use the replace, right? Replace method. Hmm. Word dot replace replace the vowel with an empty string. Does it return or does it alter the word? Replace A with it returns the word, it doesn't alter it. So I guess we can reassign word and just to be sure, let's also assign word to lowercase. And this will remove all the vowels. And then we can just return the word. Right, so if none of these conditions are met, it will still return word. Then if they're met, then they'll return word either way. So I think this should work. Yeah, now we need to return these new sentence, right? So what we can do for that is new sentence can equal new words dot David's join. You can separate it by a string and you'll get your new sentence. You can return new sentence. All right, there we go. Let's just oh, you know what? Let's just copy and paste it over. Codewars should just test it out, right? So test and okay, passed one test, okay, and it failed this one. They expected this from okay, a small. Yeah, I see. So you can't change the casing. Hmm. In that case, you know what we'll do? We'll first of all we won't convert it into lowercase, but let's also replace the uppercase version of the vowel. That should work. And huh, what happened now? That's weird. You shouldn't have converted it into lowercase. Didn't I remove two lowercase here? Or maybe it's not saved. That usually happens. Huh. Try running it again. Why is it converting it into a lowercase? I removed the two lowercase like logic here, right? You know what? Let's just test this uh, just to ensure that it's running as expected. And okay, okay. You know what? I'll just copy this and put it in here. I don't know if that was caught on stream. That was like VS Code did some sort of glitch. Anyhow, so let's see. Okay, all right. So far, so good. And what are the new words? Okay, never mind. It is giving me the expected result. And if I have my new sentence, huh? That's working all right. Maybe it's not. Yeah, let's try running it again. This is weird. Is it? Okay, what if I click on attempt? Hmm. This is weird. Can I actually log the new sentence? Let's see what I get. Okay, why is okay, what if you when you just check the output? Huh? What am I doing wrong here? Wait a second. Huh? Oh no, actually the input is lowercase here. So let's go to the instruction. All words which are three characters or less. Oh, I see. Okay, never mind, guys. I found the error. Um, so it's not strictly equal to three. It's less than or strictly equal. Oh, okay, less than or equal to three. This should work. Okay, and when you attempt the solution, 16 failed. Okay. Okay, let's see. Okay, the job that didn't remove E. Why didn't it remove E? Expected this, but got this. Hmm. I did add E, right? A, E, I, O, U. Yep. E is added there, alright. Huh. Will it give me the Okay, it's not removing the vowels here. What's the vowel here? Hmm. If it's less than or equal to 3, it returns the uppercase version. If the length is greater than or equal to 4, it tries to replace the lower version and the upper version of the vowel, uppercase version of the vowel, returns the word. Okay, what's the error here? The receipt. So whatever the word was surely had to be, yeah, greater than or equal to 4. So it should have come in here. But for some reason it did not remove E and I. Okay, I'm just gonna paste this in here and see what I get as the output. And I get, huh, okay, why didn't it replace C? Oh, because it hasn't run yet. Oh, this is very weird. If it gave me the input, I could have at least tried to debug the problem. Let's look at another case here. We didn't remove. Okay, maybe is it? Is it? I'm guessing here. If there are two types of vowels, I mean, it should still remove it, but yeah, it's removing it. All right. Oh, wait a second. This is not greater than 4 letters. Let me read the instructions again. Uh huh. I should remove vowels from 4 characters or more words, right? Then in that case, why is oh, maybe this might have been a 4 letter word. Hmm. Should I go to the yeah? If only I could unlock all the tests, right? Maybe I'm missing something. So basically, why does this still have E in it if it went through the algorithm? Means it didn't run through this. What's the word? This condition block. Less than or equal to 3, which is greater than or equal to 4. Hmm. Okay, I'm gonna just skip and unlock the solution. It's a bummer that we have to do this for the first one, but we put a rule which I have not followed for this one definitely. But yeah, we don't want to be stuck. So let's unlock the solution. E dot length less than or equal to 3. If it is, then return e dot 2 uppercase. Else match, I believe, is a regex. A E I O U. Not sure what G I is. But maybe it's to show uppercase. Hmm. I'm still not sure why my code didn't work. I have everything right. I have A, E, I, O, U. Okay, anyhow. We'll mark it as hash didn't work and move on. Okay, let's move to the next one. Actually, you know what? For this one, let me actually start uh timer so I can keep track of how long, like whether I'm overspending time or actually start a stopwatch. Alright, let's take the next one. So, um, let's see. What about this? To receive an array with two strings, create a function that will return that product as a string. Okay, alright. String, I mean, I guess this one is as, like, I, yeah, I believe this should be very simple. So we can basically do array.reduce. I mean, do we need to even, let's follow this. So, copy this. Number as string. But actually, we should take, yeah, there should be a accumulator and a current value, and the accumulator can be set to 1. We just return accumulator times number current value. Yeah, so this should work. So if I do array multiply 2, 4, 3, it should return 24, right? 4 times 3 times 2. Yeah, that's 24. What's this? Semicolon expected. Does this require 2? No. Take this. Okay. Reduce in JS. Oh. Oh, okay, I see what I did there. The current, the value for the number should go in here. So let's have return undefined. Oh, we need to return this. Okay, let's have this. Put it in here. And then we'll test, and then we'll expect 15 to equal. Oh, it should return it as a string. Should it be? Oh yeah, it's capital. Oh, okay. Oh, there we go. We solved our first Codewars cartoon stream. Yeah. Well, I guess it's our second. But whatever. Now let's what's this? Hmm. Huh. Use a template riddle. That's pretty good. Okay. Hey, anyhow. Let's go back. I guess we can write I mean we can write failed and passed and didn't work and worked. Let's take a look at another one. What is this? Cyrillic letters. Using languages like Russian and Ukrainian are different Unicode values than Latin letters. Yeah, we'll skip this one. It feels like that requires using the converting the character to its Unicode version, and yeah, let's not do that for the timing. Let's move into something else. Knight was bishop. Ooh, this is just related. Okay. It contains an integer and a string which represent the position of the piece on chessboard. Which represents the position of the pieces on the chessboard. Oh, this refers to c4, I guess. And this is d6. I mean, I get the how is this rated 7 to like uh, should be rated higher than this one for sure, right? Like nonetheless, this is interesting. I should we do this? Hmm. The bishops should be simple enough. It's just your diagonal. The knight moves in an L shape. So a knight on d4 has access to 8 squares. Hmm. I guess we can expand the chessboard to also cover negative values and then just outright remove the negative values since they're not valid squares. Otherwise, we don't even have to compute the negative values at all. Yeah, let's do this one. So this will take some time, I believe, right? I still don't understand why it's just 7Q. I believe it's underrated, so as to speak. Yeah, let's take this. Let's return this. So basically, so the way that we'll do is that we'll calculate all the possible positions the bishop can go to and all the possible positions the knight can go to. There are any common elements within both the lists, then yes, one of them is in danger. Right. So how do we calculate the possible positions? The bishop I feel would be more easier to do. So let's turn this into files and ranks. That's the so FYI, I play quite a lot of chess. So yeah. So what I'm trying to say is that Files refers to, in fact, you know what? Let me just take analysis board here, because I'm teaching chess now in this channel. So this is this horizontal row would be called rank, right? And your normal column would be called as files. So this is the A file, B file, C file, D file, and so on. And this would be your 7th rank, 6th rank, 5th rank, 8th rank, and so on. So with that logic, and this particular square would be called the D5 square, indicating that it's on um, the 5th rank and it's on the D file, right? This would be E5, this would be D4, this would be E4, this would be H8, this would be A7, this would be E7, and so on. So basically, in fact, can I remove all the pieces? No, I can. There should be some, oh yeah, board editor. There we go. So let's clear the board. Put a bishop here. So a bishop on d4 has access to these squares, right? And FYI, the center four squares are the most powerful squares in a way, because all you can put any piece on the center and they'll have the most, and they'll be the most powerful there, right? Like this bishop has access to 3 3 6, then 4, then 3 4. Is it 14? Yeah, 14 square if you also include the square where the bishop is currently at. So 3 3 6 3 9, this would make 13, and this would be 14. If you move the bishop here, same thing, it gets access to 14 squares. But if the bishop is just sitting there in the corner, it would just have access to what? So this is what? 3, 3, 2, 8 squares, right? So yeah, 8 squares. Okay. Same thing goes for the knight. The knight in the center has access to 8 squares, but at the corner it only has access to 2 squares. So now let's start coding, right? So let's have an array called let knight moves equal. How do we do this? So we get one square, right? The first would be the rank that the piece is on and the file that the piece is on. Hmm. So I guess let's have let the files be A, B, C all the way till H, A, B, C, D. All right, and we'll also have an array. Not sorry, not array. Rank column. Ranks equal 1, 2, 3, 4, 5, 6, 7, 8. Ranks in total. Now, how do I programmatically get where the bishop can move to? So I guess what I can do is I can iterate from where the bishop is, right? The bishop is in, let's say the bishop is on d4, right? So I'll calculate to the right and to the left. So I'll start a for loop which calculates these, what, 1, 2, 3, 4 files to the right, and these another one which calculates these 3 files to the left. So the for loop is moving to the right. I also know the number where it is currently at, right? So for the bishop, I guess I'll add a number and I'll subtract a number. Then moves to the next file. I'll add a number. Like I can't subtract a number, can I? Or in a way, I guess I can, right? Because it moves to the right and it subtracts a number from here. Comes here, adds a number, comes here, subtracts a number, comes here, adds a number. Comes here, subtracts a number, but since it's not like the number is not in the files that we have, so not in the ranks that we have, 0 is not a possible number, we avoid it. Right, that's one way to solve this. Same thing applies here, right? It moves to the left, adds a number, subtracts a number, moves to the left, adds a number, subtracts a number, left, adds a number, subtracts a number. And when we reach an invalid square, we just stop. I guess we can also divide it into 4, right? And okay, so function get bishop moves, right? We can have the bishop file and the bishop rank. Then first let's do an iteration towards the right, to the right side. For rank, possible rank equals 0. Well, actually, what's that syntax? For loop syntax in JS. You know that I equals 0, blah blah blah. Oh, there we go. So we get I equals 0, I less than. Okay, then we need the condition and then we increment. Let's increment first. Possible rank less than 9, right? Because we're moving to the right, it can't go beyond 9. I mean, possible rank would be equal to bishop rank. And let possible moves equal this, and we'll, I guess, yeah, by moves I mean the squares. So So, so yes, as we move to the right, I need to increment the number. We need an increment number and we need a decrement number. So let increment rank equal to, well, first of all, let increment rank and decrement rank equal bishop rank, comma bishop rank. Okay. So what happens to the increment rank, right? The increment rank plus equals 1 and the decrement rank plus plus. And you know what, let's just use plus equals 1 for the time being. Right, so it's at, if the bishop is at d4, the increment rank becomes e5. In the next iteration, it will become f6, g7, h8, and this will decrease. And let's also define the ranks and files here. So we know which file the bishop is on, right? Let's say it's D for the time being. Yes, we can do let file index equal to, we could have files dot index of whatever file the bishop is on. We have an array in Node, and I try to get the third element here. Yeah, it returns undefined. What if I try to get the negative one? Still undefined. Okay, great. So we just strictly check if it's there, right? If it actually no, never mind. We can just check if it's not undefined. Okay. So we have increment rank and then we have the decrement rank there. Oh, hey there. Hey Chickem, how are you? I didn't check the chat. So sorry for that. Yeah, I'm solving a code war problem related to what's this? Yeah, related to chess in a way. Yeah, but I feel that this particular problem is underrated in the term with regards to its challenge level, right? Should be higher. Or I guess lower when we're speaking in terms of code wars. So, let's see. For that, you need the link? Yeah, sure thing. Let me grab the link for you. Or I get the chat here. There we go. That helps. So get back to it. Yep. Nice indeed. So, um, where was I? Yeah, we are trying to get the index, and we're going to check if it's a valid, like if that file is there in the chessboard or not. So, as we go through this, we are also gonna increment our file index, right? And then we're gonna check if files file index not equal to undefined, meaning it's a valid file that exists on the chessboard for chess. Oh yeah, I need to forget to put the brackets here. So I guess what we'll do now is we'll append to, or let's just extend. Oh yeah, I don't think there's an extent for this. Right? I guess we'll just push can have yeah, you can have multiple items. So we'll have two items. Like let's have our bring our template literal here. Let possible file equal this. And then we'll have our increment rank. And then we'll also have our decrement rank. So let's check if this is working before we move on, before we move further. So let bishop moves equal get bishop moves. So let the bishop be on d4. Let's see what we get back. And here we go. Of course, it ran into another. Hmm. Can't find. Okay. Oh, because I haven't placed this. This should be inside the folder. I have to save it. Okay, let's see. Bishop rank has already been declared. Maybe the shorthand is something else. Let's just do this for the time being and we get undefined because we're not returning the possible moves. Okay, so let's see if this. Okay, this isn't correct. Oh, this should be minus equals 1. Let's just put minus minus now. This. Yeah, we've already considered the movement to the right hand side. So that would be e5. Actually, can I Yeah, you can. So that should have e5. Yeah, it should have. Okay, let's just mark this e5, e3, f6, f2, g7, g1, h8, h0 should not be valid. For that, we'll add a statement and that should work. Right, we're getting there. So, how can we do this the easy way? I guess before pushing, we'll just check. So if increment rank isn't okay, so we need to use includes because for some reason JS doesn't support the in operator with that is. Not for some reason, I know the reason, but yeah. If ranks dot includes, so if it doesn't include the increment rank, so if it includes the increment rank, then we push this. Similarly, if we will just copy this over. And okay, this needs to be wrapped in brackets. And let's see. Hmm. Okay, this needs to be decrement rank. And maybe typo that. Alright, so we get all the possible bishop moves to the right hand side. Let's do the same for the left hand side. Yeah, I mean, it's the same logic, isn't it? Except we subtract rather than adding. We'll clean the code afterwards. So let's just write this out right now. The condition becomes the inverse. So possible rank should be greater than 0 and possible rank minus minus. If I run this, that didn't work. Okay, let's see why that didn't work. Greater than 0 and possible rank gets subtracted. Maybe I didn't save it. Never mind, I saved it. Alright. Let's bring our debugger. Okay, let's see what our possible rank is. Oh, file index should be subtracted. But what is our file index? We need to reset these values. I can see possibilities of having more clean code, but we'll fix it later. Okay, I guess. Okay, let's remove let. We run this and we just run this and we get, hey, we get 14 squares. So let's see if they're right first of all, and then So e5, e3, f6, f2, g7, g1. I believe that should be a shade. Yeah, it's a shade. Then we have the same squares repeated again. So what happened here? Oh, I didn't subtract this, did I? And let's run this. So e5, e3, f6, f2, g7, g1, h8. Then we have e. Oh, let me just mark these squares again. Don't worry, they're verified. C5, C3, B6, B2, A7, A1. All right, so there we go. We're getting there. So the bishop function works, and we'll clean it before submission. For the timing, let's just write the get knight moves. Let's have the knight file and knight rank. Just put this comment in here too. So let's see. Okay, let's put the bishop on the corner and bring our knight to the center. Same thing. The knight is currently on. Okay, why isn't that zooming in? Okay. So the knight is on d4 right now. And the way the knight moves would be more tricky, right? So knight can go to e6, f5. Oops. So e6. Okay, you know what? I'll just mark this squares. E6, f5, f3, e2, c3, b3. Sorry, c2, b3, b5, and then you have c6. So what's the pattern here? Actually, they're similar, aren't they? Except for the knight, you increment. You just have two iterations to the right. That's it. You don't continue to the end. You add two, decrease two, then you add one, and you decrease one, and it's over. It's finished. Same thing for the left side, right? You add two, you decrease two, and then you add one, you decrease one. Add two. But I think you get the point. Um, so again, just to make it clear, add two, decrease two, add one, decrease one, add two, decrease two, add one, decrease one. That's it. The algorithm applies if the knight is in the corner too, right? Because we here we don't have the right hand side, so we just calculate the left hand side. So the knight moves down to up to, but that's an invalid square. The next time it moves down one, then up one. But obviously that doesn't exist, so it isn't counted. Great. I think we'll apply the logic and here we go. Let's get to coding. So it would be interesting to see if anyone has probably they would have come up with a one-liner solution. But yeah, let's check. So knight file. How do we write this to code? Have our files and ranks again. We'll also have possible moves. same thing. All right, so to the right side. Yeah, we should have just called it rank. Now we'll have to rename everything. So to the right side, right? So for possible rank, possible rank should be less than, like, just do two iterations, right? So possible rank plus two. Actually, it should be or less than or equal to, right? So if this is three, we can go four, five, but not more than that. And possible rank plus plus, yep. So if it's a first iteration, we want to increase to, if possible rank minus night rank, right? If this is if this is equal to one, it's rather strictly equal to one, then we're gonna set increment or decrement value to be sorry, two. I don't think we need to even do this, right? Like if the value is, if this value is two, then we can make it. Okay, let's have a ternary condition rather. So we'll call it increase, decrease value can be, so basically we copy this. It will be two if this is met, else it will be one. And this should be minus equal increase decrease value, and file index, of course, it will move towards the right, so that's all good. I guess the rest of the condition remains the exact same, so yeah, except, did we call it bishop moves? We call it possible moves, not bishop moves. So I think they should work. Let's see. That knight moves equal get knight moves. What happened here? Unexpected token. Where did I write the code then? Okay, I wrote it inside here. Um, it's taken everything that's here and move it to here. Unexpected token. Hey, why did we get that now? Maybe let's just add a return statement here. That fixes it. No, it doesn't. Get night moves. Unexpected token. That has that. That has that. And what if I remove it? Get night moves is not defined. Hmm. Okay. This is frustrating. Does this work? Does this work? Okay, that doesn't work. Okay, why doesn't that work? Why can't I have a problem? I expected. Oh, of course, of course. It should be. I didn't use a function keyword. Ah, okay. Anyhow, so where was I? Night rank. Um, let's see. Don't I? So file index. I need to calculate this, right? So yeah, let's copy this. Move this here. Now what? Women rank is not defined. Bless me, I guess. Okay. So let's see. Jesus. Does this dust or something? Yeah. So equivalent rank is not defined. Ah, okay. Okay, is that dude? Stop now. Okay, let's get back. Line 16. Increment rank. Okay, I need to set this to the night rank. Okay, let's see. We should return the possible moves, and am I not console dot logging it? Yeah, running into some infinite loop or something. Let's see. And it should be it's not over, okay. What's the possible rank? At 6. This should be less than or equal to night rank plus 2. And that should work. So so it can work as expected. You got e4, f5, f3, g4, g5, g3. Let's mark them. We have f5, f5, f3, g5, g3. Okay, if we can make it e6, e2, that should work. So let's check this. So what's the increment rank right now? It's at 4, right? This value should be what? It's set to false. Is this equal to true? That's false. Huh. Interesting. Ternary operator JS. Was it returning a Boolean value? Return. Is it a member? Then return this. Oh, I think I got it wrong. It should be the condition. So basically I'm asking a question, right? I should remember it like that. So is this true? Return this, else this. And this should be true, right? Possible rank minus night rank. Possible rank is at 0. Okay. So when I'm moving to the right hand side, the possible rank would be greater, right? Why is it possible? Why is this set to 0? First of all, let's fix this ternary operator and come back to this statement. Let's look at possible rank. Okay, it's at 4. Great. So it's possible rank minus. Okay, that should be equal to 0. But we don't want possible rank to start at that, right? We want it to start at 1, like plus 1. Like start from the next rank. Okay, alright. So far so good. We got e6, e2, f7, f1. Let's just check that out real quick. We get e6, e2. It should not be f7, f1. I guess doesn't work as expected because it like it increases two value, yes, but then it increases one value from here, right? Like we assumed increase, then increase like this. How about I flip it? How about I start from the this area, right? So I can increase one, and then I can just increase two. But then I need to change the logic, which I don't want to do. So I guess rather than making it one, let this be two, yes. But I want to decrease one, so it can be negative one. I feel like this should work. Yeah, there we go. So F5, F3, E2. Great. Now we just copy this for the left hand side and should work. Same thing except two changes are gonna take place. First is that we're gonna subtract the file index first and foremost. This is gonna decrease, not increase, and we're gonna inverse the sign here. File index minus minus, come in here. Increment drag is at 4. So this is to the left hand side, right? Yeah, it should increase, decrease 2. Should be minus 1. And E3, E5, F2, F6. We get G4. Okay. Yeah, something's wrong there. Let's just pause something here. Should be oh, I need to minus this. Okay. No, wait a second. That's towards the right hand side, right? Oh shoot, I change things in my. Hopefully, I haven't changed it as. I didn't change it very much. Okay, possible moves. C6, C2, F5, F3. Okay, that's working. So this would we start at the lower rank, right? Then we'll inverse the sign here. This would decrease for us. To increase decrease value is negative one, which okay. Am I getting E4? Oh, because I have to reassign file index. The possible rank starts at 3. Okay, alright. Great. Um, then we check if it's less than or equal to this. We check if it's less than or equal to night rank plus 2. What? But we only want 2 iterations to the right. Night rank is 4, right? Minus. It starts at 3, and I check if 3 is less than or equal to 2. It needs to change to greater than. File index is to ABC. Because it's at D4, it's calculating C. Yeah, okay. Uh-huh. And what's the possible? Why are we getting 4? Should not be 4. This, I feel this condition should also change, right? Because I'm doing the reverse of what I want. Increment rank is at 7. Why is it at 7? Just because I did not reassign the original values. Okay, all right. Increment value is at 6. We want it to be at 6. Yes, great. And this should be 4. So not 4. 2. Yeah, 6 and 2. Okay, that's great. Now we need to get 5 and 3. Yeah, let's check possible moves. Yeah, 6 and 2, great. And it should not be 2. It should be what number should I add to 6 so I should get negative 1, right? But it's not working because here I guess it should be the opposite. There we go, that worked. How long did that? Oh, geez, we're almost 1 hour and okay, alright. Anyhow, it's working now. We got the bishop moves and the knight moves function working. Um, yeah, I guess for the timing, let's just finish off with the main function. So basically, we're just checking. Let's just go to the problem statement again, real quick. Knight is the knight can capture the bishop. Knight moves is gonna be get knight moves. Bishop moves is gonna be get bishop moves. To select have let here. Now how is the position given? So rank comes first and then the file. So knight position. Um, it's 1, 2. I believe it's slice, isn't it? Okay. Inverse array in JavaScript. Reverse. Okay, we can just use reverse and then. All right. Okay. So we can just do reverse and then we can use the. I believe this would be called the spread operator. So let's place the bishop on d4 and knight on e5. It was his bishop. Knight position would be on e3. It should be the other way, right? 5e. And bishop position would be on um d4. Okay. So knight position. Sorry, I mean knight moves. Okay. and the bishop can move on. Okay, did I accidentally remove the post? No, that's working. Okay, this is weird. Hmm. Let's check the bishop position. Uh, d4. Hmm. Why did that work now? Bishop moves. Okay, alright. What's happening? Um, this returns, but why do you have this bracket here? Oh, of course, because I need that bracket to be there. Why? What's happening here? When I do it the second time, it doesn't work as I expected. Very weird. Okay, you know what? Let's just do it the normal way. Why am I getting undefined? Uh huh. What's happening? Does it even come in here or what? Comes in here. It has possible moves as an empty array. Bishop 5, bishop rank. Oh, I see. Is this the reason? Okay, finally we get the knight moves and bishop moves, and now it's just a couple of flip statements, and we should be good to go. So we need to check if there are common elements between two arrays, right? So basically, in this case, the bishop can capture. Oh, actually, we also need to consider the position, right? Oh yeah, I mean, basically what we'll do is we'll get the current square the knight is on. The knight is on e5. We can see that the bishop can move to e5. Therefore, the bishop can capture the knight. So yes, what we'll do is we'll write current bishop square is gonna be, let's bring our template literal thing. It's gonna be equal to bishop position. This would be the rank. So let's copy this and also just, you know what, let's just do this instead. Um, Never mind, let's not get fancy. Let's just do it the simpler way. So if the if the bishop position, sorry, if the current bishop square is in the possible moves where the knight can go to, then we're gonna return, really we wanna return knight and HT. Else if the opposite is true, that is the place where the current knight lies can be attacked by the bishop in the next move, then we can return bishop. Else if none of those are true, then we just return, I believe it's none, or what is it, what do you want me to return? Yeah, return none. I believe this should work. Why is everything this? Okay, I need to get rid of these extra brackets. Not brackets, curly braces, aren't they? So knight versus bishop. This should return. So knight is on e5, bishop is on d4. This should return bishop because the bishop can capture, the knight. Great, amazing. Let's copy this and here we go. What now? A log bishop. Expected none to equal bishop. Make a few adjustments. Okay, let's see. The bishop is on d6. And it can move to all these squares. Where did my code go? Yeah. And knight is on c4. And they can move to all these squares. This should return knight. And then, okay, I guess this is a second example there. The bishop is on c6. The knight is on g2. And they should return bishop, yes. Why isn't g2 included in the possible bishop moves? d7 is included, d5 is included. e8, e4, f3, b7, b5, a8, a4. For some reason, g2 and h1 are not included. Why? Bishop is on c6. Let's see what the file index is at. Is that should be to the left side. So file index, file index. So it's at D right now, and it's at E, D, E, and next it should be at F. F, and okay, let's look at this. X is out of the loop. Oh, because the our solution only works until it reaches, like if it goes above, it doesn't work, right? Like it gets cut off here because this doesn't work. So I guess we have to add a and, right? Possible rank is less than 9. Should be less than 9, yes. At the same time, it should be or less than. Okay, let's see. Breakpoint. And possible rank is at 8 right now. Let's also check if the file is exceeded, right? Like the file index. Yeah, let's check that. I mean, the file index should be greater than what? Files.length. I guess we also need to do -1. So what that would mean is that as I mean files.length would return 8 ranks in total. So if it can be less than this plus 1, we should be good to go. Because I can still access 0, 1, 2, 3, 4, 5, 6, 7. No, I guess this is enough. Then work. Okay, let's see. That didn't work. This should work for the next iteration too. Hmm. Logical and this. Okay, this is the bitwise operator. That's the reason. And it still didn't work. Why? This returns false, right? No, that should return true actually. I should use over here, right? Not yeah, not the other one. This should be false or false. Both should be false. Yeah, okay, there we go. We got but I guess the same thing needs to be applied to everywhere. But here what? Here we'll be doing will always be less than. So it should be greater than 0. Greater than or equal to 0. Let's apply the same thing for the knight move. And let's apply the same thing to here. Let's copy. And let's save and what unauthorized? That's a new one. Alright, that passed. And okay, now what? Knight to equal. If you don't give me the test that is required, then how will I know which isn't working? There is way to see test inputs, yeah. And okay, let's do it that way. Yes, we have no choice. It's working for the test here, but it's not working when I attempt. Okay, let's just do console.log. But actually, let's just do the current bishop square. Show me the log. All right. Bishop is on d4, knight is on d4, and returns. Why is it printing? Okay, I see. Bishop is on d6, knight is on d6. Huh. Wait, what? This is not even possible. How can two squares be on the same square? I mean, two pieces be on the same square. Wait a second. Bishop is on a4, knight is on a4. What? Bishop is on. Okay, oh, okay, I see. Never mind, that was my mistake. I don't. Bishop is on d6, knight is on c4, and what? It's failing? No, the last one fails, right? So bishop is on d1, knight is on e1. Expected knight to equal none. It's failing at that. Bishop is on d1, knight is on a1. Knight on a1 can move to just b3 and c2. So why is it okay, it gives me b3 and c2, but it also gives me d1, e2, f3, g4, h5. D1, E2, F3, G2, F5. Did I invent a new piece or something? Um, E2, F3, G4, H5. E2, F3, G4, H5. Wait, isn't that a diagonal? E2, F3, G4, H5, D1. Huh. Okay, okay. Let's just fix this. Let's fix this. So nice on A1, right? Let's get the knight moves and see what's going on. Let's just make it moves. I'm tired of changing things. It's not working as expected. Let's see why. So get my moves to the right side. And this is the second iteration. It should it should exit now, but it is not exiting. Why? What could be the reason? Uh-huh. Oh, because it has not reached the but in that case the increment rank and decrement rank should be negative, right? So it should not register the value. But I guess this turns out to be -1 and hence it increases it. So this logic works for the bishop moves, but it doesn't work for the knight moves. I guess what we could do is okay, let's just remove this line, okay, for the yeah, I don't think we need this for the knight moves, do we? What do you mean by bishop? Um, B3 and C2. So yeah, let's remove that just for the knight moves. And if I attempt, all right, there we go. It worked. Um, yeah, no, it makes sense. I mean, like the knight doesn't go all the way to the board, right? We purposefully just check 2 rows and we quit, so we don't need that logic. Oh, we finally did it, guys. And it only took us what 1.5 hours. But yeah, this should not be 7 Q. Okay, yeah. I'm gonna tidy the code a bit before I submit, but I guess we'll just submit it. Yeah, we'll just submit it. It's fine. There we go. Let's check what the ooh Lord. I told you right people would have some interesting solutions. Let's check this out. But before we do that, let's add the relativity. We changed the solution to work here, didn't we? Yes, we did. Okay. In that case, let's add the link. No, not the solution. I want the I we should be able to go back. So there we go, and we can write pass. There we go. I guess if we yeah, maybe the next time that we do the Codewars session, we can go back to the first problem So this is a relatively easy problem. I don't know why it failed. Yeah, me. Yeah, we'll have to check. We'll have to check. Um. Anyhow, let's look at the solutions provided here. NP. Okay. Uh huh. If wait, what is this? This is an interesting solution. Let's also just create test.js, right? We'll delete it afterwards. And let's do knight versus bishop. Knight is on e5, and the bishop is on d4. This should return bishop. That output equal this console.log the output. Let's debug this. It returns bishop, but how does this work? Knight position is what is what does this method do? Character Kodat. Oh, I guess it returns the Unicode value and returns an integer between 0 and yeah, it returns the Unicode value. Okay, and what exactly is it doing? It takes defects. What's defects? If defects is equal to def_y, return bishop. Oh, difference between the x, okay, x coordinate and difference between the y coordinate. Huh. This okay returns the positive difference. In other words, so we gave he converted both of them to numbers and is checking if the distance between both of these points are equal. If they are, but then what if I put my knight here? This shouldn't work, right? Oh, for that he checks if the difference between x and y is equal. So in this case, this is equal to this. This is equal to this. Like both of these distance are the same. That's pretty clever, isn't it? But in this case, it's not the same. Huh. Interesting. That's pretty good. And what about the knight then? Oh, he just does a or condition. Oh, I believe this somehow translates to whether it's like in an L formation. That's pretty clever. Okay, cool. And of course, there are a million solutions here. Anyhow, we solved it with our own solution, and yeah. All right, I guess I'll be ending the stream here. It's been a pretty long while. Pretty, yeah, it's been a while since I did one of these longer streams, but I think it was worth it. We attempted three Cod War problems and we were able to solve two. Believe we should have been able to solve the first one also, but we didn't spend more time there. Anyhow, I guess I'll be ending the stream here and I'll see you in the next one. Alright, take care. See ya.